right, we're continuing on with inverse functions. Do you remember if you have a normal function, not worrying about trig functions yet, and you take the inverse of that function, or the inverse is your argument of the function? Do you remember what those values equal? Yes, no, maybe so? X. So in other words, it's like you undid the function and you just get your input back. So the same thing works with trig functions. If I have the inverse and then my function, or my function in the inverse, then I get my input back. And once again, we need to worry about restricting the domain. So if I look, the argument is what's inside parentheses. That's my input. So I need to be sure, if I'm going to take sine inverse of something, I need to be sure that this something is in the domain of my inverse, which last lecture we said was negative pi over 2 and pi over 2. And then if I'm looking at just my sine, and notice the difference here, that the sine inverse being inside, if I want to take the sine of something, then I need to be sure I'm between -1 and 1. All right, and that's, notice the difference, which one's inside, which one's outside. All right, so if I want to find this value, I want to find the sine inverse of sine of 8. Well, the first thing, oops, I didn't mean to do that. The first thing I have to do is figure out, is pi over 8 in this interval? Okay, and that's what you got to ask yourself. Well, how do I know where pi over 8 is? Well, if I have pi over 8 and I'm looking to see, is it in this interval? The problem is, like with fractions, I can only compare fractions if they have the same denominator. So I could make this 4 pi over 8 and negative 4 pi over 8. All I did was multiply the tops and the bottom by 4. Why am I doing that? Because I want to be able to compare and see, now is pi over 8 in this interval, and it definitely is. So my answer is simply pi over 8. Okay, so that's the first thing you have to figure out. Are you in that interval? If you are, it's easy. Then it's just whatever this value is your answer. When these get tougher is when you're not in that interval. Hint, hint, wink, wink. So I look at this one and I see I'm keeping this here on the bottom so you can see that which interval my domain needs to be in. And I look and I say, well, where is 5 pi over 8? Is it in this interval, the negative pi over 2 to pi over 2? I don't know. Well, if what I do is I always look at pi, because, so pi right there, because pi is something easy to match the denominator. So if I have pi, isn't that the same thing as 8 pi over 8? So I'm trying to figure out then, is 5 pi over 8 in this interval? Well, I could even go up to pi over 2 and turn this into the same denominator, 4 over 4, which is kind of what we did on the last one. And I get, so this is 4 pi over 8 to 5 pi over 8. So apparently 5 pi over 8 is in this interval, which is not the right interval. So what I have to do is I have to put it in the right interval. If you remember, sine is the y value. What does it matter if I use this y value or I come over here and use this y value? It shouldn't matter, right? Because it's the same y value. So basically that's what I'm going to do, is I'm going to move this, but I have to figure out then what's my angle. All right, I'm giving you the answer here, but let's talk about this. So if I know where 5 pi over 8 is, so this was 5 pi over 8. I'm in the wrong quadrant, okay? I'm not in the right domain. And I said that my pi here is the same as 8 pi over 8. Well, notice if I take and subtract 8 pi over 8 and 5 pi over 8, I get my angle. So pretty much what you're doing is you're taking pi minus your angle to move it. And you just have to do that whole, all the kids are doing it these days where you get the least common denominator. And so you just have to do that to move it over to the right domain. Okay? These students struggle a little bit with these of finding this value, but once again, I think students struggle anytime you deal with something with fractions, so get these down. All right, sine of sine inverse. Well, if you remember back here, the inverse was on the outside, so this is something different. So what we're doing is we're noticing here that this isn't the same. So if this value in my parentheses, if that value is in this interval here, and it is, then that's my answer. If I look at 1.5, well, that's not in the domain, and that's what we just say. It's not in the domain. All right, so these take a little practice. Like I said, especially the first ones up here. If you're not in the domain, how do you get in the domain? All right, well, if we have inverse sine, I'm sure you guessed we would have inverse cosine. Not 1-to-1. How do we make it 1-to-1? We restrict the domain. This one we restrict from 0 to pi. So this is my restriction to make my cosine 1-to-1, and that's going to allow me to now have an inverse function. Because my function's 1-to-1, I can have an inverse function. How do we find the inverse? We swap the x's and the y's, just like we did on the sine. And then up here, notice we're flipping once again the domain and range. So the inverse function, the domain is -1 to 1, and the range is from 0 to pi. All right, so if I want to find an exact value, once again, when we're just looking for the cosine inverse of some particular point on the unit circle, we're looking for the angle. I want to restrict my domain, which is from 0 to pi. So I have to look in this box and figure out where my cosine is going to be negative square root of 2 over 2. Remember, cosine is x, so it looks like right there at 3 pi over 4. So works the same way as the sine, but this one's restricted from 0 to pi. All right, just as I mentioned with the sine, same thing works with the cosine, and we just have to be sure we're within our domain. So if I have cosine of 4 pi over 5, my first question is to try to figure out, is this in my domain? And I think it is. And once again, the reason why I love pi, I love the pi, because that's easy to match denominators. So that would be 5 pi over 5. So that means that 4 pi would be backed up here, a pi over 5, right? And that's what my next picture shows. And because it is in that domain, then that's just simply our answer. All right, the next one, want to find this exact value. You got to figure out where in the world is -2 pi over 3. Okay, if you remember even and odd properties. Do you remember even and odd properties? Hopefully you remember even and odd properties. If you remember even and odd properties, this is just simply the cosine of 2 pi over 3. Okay, so in other words, this is going to remain the same as 2 pi over 3, which is going to give me my answer. Next one, bring the cosine inverse inside. Is this in that interval? I believe so. And so as long as you're within this interval, like once again, these are easy. If you're not in this interval, it's just not in the domain. And we'll continue on with the inverse tangent next time.